Today we're getting into 7.3, multiplying and dividing rational expressions, but we're not actually multiplying and dividing today. We're going to start with some simplifying. I promise it does not require your phone. Here's the thing. You have every necessary piece of information needed to simplify rational expressions. Heck, you have every piece of needed information to multiply and divide rational expressions. Because this is a rational expression. It's a ratio. It's a fraction. How do I simplify 15/24? Figure out what's the biggest thing that divides out of both, which is 3. You get 5/8. Now, why 3? It's the what? It's the greatest common factor. So, when you are simplifying rational expressions, what you're essentially doing is you're dividing out the greatest common factor. Now, if you're going to divide out the greatest common factor, that means you have to know what the greatest common factor is, which means for larger polynomials, they have to be factored. When it comes to just monomials, to just regular numbers, we generally just straight up look at the numbers and say, well, this is what divides out. But another way that we could do it is we could have looked at this as a factored form. We could have looked at 15 as 5 getting multiplied by 3, and 24 as 8 getting multiplied by 3, and then recognized that 3 over 3 is equal to what? 1. So these essentially canceled out by becoming 1, and what does multiplying by 1 do? Nothing. Multiplying by 1 doesn't do anything, which is why it became 5/8. That process is going to get us through simplifying rational expressions. Now, before we actually get into simplifying rational expressions, there's one other thing we got to talk about with it, and it's something known as excluded values. Excluded values are values of a variable that make an expression undefined. What does it mean to be undefined? Kind of. It's kind of related to no solution, but that implies solving. It means not defined. It means something that does not have a definition, something that we can't do. In math, what's something we're not allowed to do? Divide by 0. With rational functions, what makes them undefined is whatever makes denominators equal to 0. Now, you never had to deal with this with the rational expressions that you dealt with back in elementary school, i.e. regular fractions, because did you ever put 0 in the bottom of the fraction? And no, you just didn't do it because they were plain numbers. But when you put variables in the denominator, 0 might be amongst them. So, Today we are going to simplify and find excluded values. And it's going to be rational expressions. Now, when it comes to these rational expressions, you have to pay attention to what type of polynomials you've got going on. Because in order to simplify rational expressions, in all technicality, they need to be fully factored so that you can see what the greatest common factor is. There's a slight exception to that rule. We're going to start with the rational expression 45x to the 8th power yz over 60x, y being put to the power of 3z. Looks ugly, looks scary, but it's not so bad. I need things fully factored. Can I factor the numerator? If there's no addition or subtraction, we don't factor it. Factoring requires plus and minus signs. Can we factor the numerator? No. Can we factor the denominator? No. This is the exception to the rule on being fully factored, because essentially it is fully factored. When there's no addition or subtraction, you treat it like a regular fraction and you just simplify it by seeing what divides out of it. When there's numbers and variables, you work with them in pieces. Start with the numbers. What divides out of 45 and 60? 15. When I divide 15 out of 45, what am I left with? 3. If you don't have a calculator, you should grab one. Doesn't need to be a graphing calculator, but you should have a calculator. When you divide 15 out of 60, what are you left with? 4. So far in the simplified form, I've got 3 on top, 4 on bottom. Okay, I got an x to the 8th on top and an x on bottom. What's the biggest thing I can divide out of both x to the 8th and x? Just a singular x. Now, when I divide x out of this, it's going to disappear. X to the 8th getting divided by x, what am I left with? X to the 7th. When you're dividing variables, you're subtracting their exponents. So I'm left with an x to the 7th power up top. I've got y and y cubed. Biggest thing I could divide out of both? Y, or y to the 1st power. That one cancels out, and on the bottom I'm left with y squared. Z over z cancels completely. This is the simplified form. It's not my full answer though, because what's the other thing it wants? Excluded values. Now, excluded values are what not only make the simplified denominator equal to 0, but what make the original denominator equal to 0. So, to find them, take your original denominator, which was 60, x, y to the 3rd power, z, and set it equal to 0. How do we solve that? Would you agree that it's just a bunch of stuff getting multiplied together equal to 0? It's 60 times x times y cubed times z. What's the only way you multiply a bunch of stuff together and get 0? You multiply by 0, which means split it, just like you do when it's factored. If all of it's multiplied, you can split and set equal to 0. 60 is 0, x is 0, y cubed is 0, and z is 0, and you solve each of them. 2 of them are nicely solved already. X is 0, z is 0. 60 equals 0. doesn't make sense. The constant's not going to do anything. If y to the third power is 0, what does y have to be? 0. Y to the third power is y times y times y. The only way you get a bunch of stuff multiplying together and giving you 0 is if you're multiplying by 0, which means this is giving us y equals 0. But there's one slight shift we have to do. Excluded values are what it's not allowed to be equal to. I don't want equal signs. I want not equal signs. Change them to not equals. My excluded values are that x is not allowed to be equal to 0, y is not allowed to be equal to 0, and z is not allowed to be equal to 0. So, this is the beginning of simplifying rational expressions. If there's no addition or subtraction, just simplify in pieces, and to find excluded values, set the original denominator to 0 and solve. Next example, 2x plus 4 over 3x plus 6. Problems like this tend to cause some of the biggest issues because the first thing people want to do is they want to cross off those x's, or they want to simplify the 4 and the 6. But you cannot do that. Simplifying this as written is like taking the fraction 2/3 and saying 2/3 is 1 plus 1 over 1 plus 2. Would you agree that 2/3 is 1 plus 1 over 1 plus 2? And crossing anything out when it's in this form is like saying I can cross these ones out, and therefore 2/3 is equal to 1/2. Is 2/3 equal to 1/2? They're not the same fraction, so you cannot cross anything off here. The reason crossing things off works is that you divide it out of the entirety of the top and the entirety of the bottom fraction. The only way you can do that is if it's fully factored. Can you factor 2x plus 4? How do you always start factoring? GCF, what's the biggest thing that divides out of 2x and 4? 2. Now, if it's a simple factoring like this, I'll factor it right in the fraction. If it's a more complex factoring, I typically take it off to the side so I don't have to keep writing the fraction. When I factor out the 2, what am I left with? X plus 2. Over. Can I factor the denominator? Yes, what's the GCF? 3. What am I left with? X plus 2. Can I factor them any further? No. What's the biggest thing I can divide out of both the top and the bottom of the fraction? What do they have in common? They have an x plus 2 on top and bottom. Those will cancel out. Binomials will cancel out with binomials if the exact same binomial is on top and bottom. Then you can cross them off. The monomials, which is the 2 and the 3, will simplify like regular fractions. Can I divide anything out of both 2 and 3? No, which means that stays 2/3. That's its simplified form. Am I done? I also need excluded values. How do I find excluded values again? What was that? Specifically start with the denominator equal to 0. The original denominator equal to 0. Now, keep in mind, they're not always going to solve the same way. Do I typically split 3x plus 6 equals 0 to solve it? No. How do I solve 3x plus 6 equals 0? Subtract 6 and then divide by 3. I get x equals -2. Before I'm done, what do I do though? Change it to a not equal to. When simplifying rational expressions, factor, cross off binomials if they're the exact same, simplify monomials like a regular fraction. I just got 2 more examples for y'all. But otherwise the process is the same throughout. The only thing that's different is the factoring. I want to simplify this. Can I simply cross off the x squareds right now? No? Why not? Has nothing to do with the 3. Because if I simply had 3x squared over x squared, could I cross off the x squareds? Yes. You cannot cross anything off unless it's fully factored. In other words, you see plus and minus signs? They need to be in parentheses before you can be crossing anything off. And you can't just randomly add parentheses unless you add it to entire things. So you gotta factor. Can I factor 3x squared minus 27? Now when I do that, that's gonna be a multi-step factoring, so I'm gonna pull that off to the side. I know it's gonna be a multi-step factoring because I noticed the GCF is just a number, but it's still gonna leave me with an exponent. So I'm gonna have to do multiple steps. What is the GCF? Three. Divide out of 3, what am I left with? X squared minus 9. Can I factor it further? Yes. How do I factor x squared minus 9? Difference of squares is one option. What's another option if I don't know the difference of squares? AC method, the full AC method, or the shortcut? Either of them would work. I personally like difference of squares. I recognize that this is a perfect square. What's being squared? X. What's being squared here? What's squared to get 9, in other words? 3. And is it a difference? Yep. Difference of squares goes to double parentheses and says the first thing that got squared starts them both. The first thing that got squared was the x. The second thing that got squared ends them both. What was squared to get 9 again? 3. And what's the signs in there? One's a plus sign, one's a minus sign. Don't forget to put the GCF back on. Can I factor it further? No, there's no exponents left. That's my numerator. Can I factor the denominator? Yes. You don't have to pull it off to the side if you notice that it's one step. If you're not sure, pull it off to the side. How do I factor x squared minus 8x minus 33? Shortcut, because GCF is 1. Shortcut, I can do because the coefficient of x squared is 1. Two things that multiply to negative 33, but when I add them, I get negative 8. Negative 11, positive 3. Do I have to do the rewrite step? The write it as 4 terms, in other words? No, not when it's the shortcut. What's a factor into? X minus 11, x plus 3. That's the advantage of the shortcut. Once it is fully factored, then I can look for simplifying. Is there anything that I can cross off both top and bottom? We have an x plus 3 on top and bottom. The x minus 3 and the x minus 11 have nothing to match with, so they are going to stay. The monomial is a 3. For it to simplify, it has to have another monomial on bottom. What number's hanging out here? A 1. Do a 3 and a 1 simplify? It's just 3 up top. So I am left with 3 x minus 3 over x minus 11. Now, since x minus 11 is alone, I don't need the parentheses anymore. I am perfectly okay if you leave this as an answer. Technically, is it the most simplified form? No. Technically, the most simplified form would distribute the 3 back through and give you 3x minus 9 over x minus 11. That is what the answer key will have as an answer, because that's what the book prefers. I don't care if you leave it like this. By the way, one thing I commonly see when people do this is now they start trying to cross off the x's. Can I cross off the x's? No, because you have a subtraction not in parentheses, so it cannot be simplified further. What do I still need? Excluded values. For excluded values, what do? Denominator equal to 0, but which denominator? The original. Or there is a slight shortcut that you can do. Because how do you solve x squared minus 8x minus 33 equal to 0? Can't use square roots, can't add the 33 to the other side. It's quadratic. To solve a quadratic equation, you've got things like factoring and quadratic formula. Didn't we already factor this? Slight shortcut. Set the factored form equal to 0. If that's what you said, I missed it. How do I solve that now? Split them up. The only way things multiply and get 0 is if you're multiplying by 0. X is 11. X is negative 3. But those are what x is not allowed to be equal to. Those are what, if I were to graph the expression, those would be vertical asymptotes. I got one more example for y'all. Where do we start? Start by factoring. Factor the numerator, factor the denominator. You see pluses or minuses, you gotta factor first. 5x squared minus 10x. GCF? Just 5? 5x. Leaving me with x minus 2. Can I factor it further? Does it have exponents left? If it doesn't have exponents left, then GCF's all you got. That's the top. Okay, the bottom looks a little more complex. 25x to the fourth minus 175x cubed minus 750x squared. Okay. Greatest common factor.
25x squared.
All of those divide by 25, and yes, x squared. What am I left with?
X squared.
30. Can I factor it further? Yeah, or at least I can try. How? Shortcut method? Two things that multiply to negative 30 but add to negative 7. Negative 10, positive 3. I think I wrote down this problem wrong. It works. So, I still got my GCF, and since I'm doing a shortcut, double parenthesis, they both start with x, and I got a negative 10 and a positive 3. Yeah, I wrote down this problem wrong, but that's okay. Do you notice none of the binomials match? None of the parentheses match? I'm not crossing off any parentheses. It doesn't mean it doesn't simplify. Look at the stuff that's in front, those greatest common factors. These, when it doesn't have the pluses or minuses, the GCFs, you just see what divides out of both of them. What divides out of both 5 and 25? Out of the numbers, I can pull out a 5, leaves me with a 1 up there, leaves me with a 5 down here. Out of the x's, take out a regular x, leaves me with an x to the first on the bottom. On top, I'm left with x minus 2. Technically, I'm left with a 1 in front of it, but do I really need the 1 in front of a parenthesis? No. Over 5x, an x minus 10 and an x plus 3. Sometimes, it's just not going to be pretty. And that's okay. We simplified what we could. Do not cancel out these x's. Why can I not cross off this x in the top? Because the minus. Technically, there are still parentheses hanging out right here, holding that x minus 2 together. You cannot cross it off unless there's an x minus 2 on the bottom, which there is not. What's the only other thing I have to do on this problem? Excluded values. What am I setting equal to 0 again? Original denominator. How do you solve a quartic polynomial equal to 0? Factoring. Didn't we already factor it? Once it's factored, split it up and set it equal to 0. 25x squared equals 0. X minus 10 equals 0. X plus 3 equals 0. X is not allowed to be equal to negative 3. X is not allowed to be equal to positive 10. Divide by 25, x squared is 0, which gives me x is not allowed to be equal to 0. So, there's a reason we did rationals right after polynomials, because of that heavy reliance on factoring again. Factoring is going to continue to come up. We are on page 374. Both today and tomorrow we're on 374, so please write day 1. Problem numbers 1 through 8. And then the rest of them are really broken up. 19, 44, 45, 53, 54.